For my physics project, I decided to test the principle of zero torque and static equilibrium by placing objects of different masses at different distances around a rotational axis. I took creative liberties to replicate the balancing act PhET lab we did earlier in the semester, but instead of a seesaw, creating a hanging, rotating, baby-mobile-like sculpture. I took clouds of 3 different masses and raindrops of 2 different masses to calculate my unknown mass of the lightning bolt and figure where to place it. Similarly to the balancing act PhET lab, I knew all of the masses of the clouds and raindrops and placed them at different distances in order to balance out the lightning bolt. Once they were balanced, I was able to calculate the mass of the lightning bolt as the total torque equals 0. My procedure was as follows. Firstly, I took the masses of all my clouds by putting cotton balls around a styrofoam bowl. Secondly, I beaded some string to represent raindrops in the weather motif. Then finally constructed my lightning bolt, which would be my only unknown. In order to do the calculations for my unknown mass, I had to record how much of each mass I had on either side of the axis and then calculate the distance. This is a closer look at that algebraic problem where I have each mass with their distance and then obviously gravity, and then the x with the 2 centimeters and gravity in order to solve for it. This shows how I got to the conclusion of 3 grams due to the torque equation, where mass times distance times gravity will give you the torque. I organized this data of the torques and the masses into 2 data tables for either side of the axis. Once I had my totals, it was a simple algebra problem to get to 3. Upon actually weighing my lightning bolt or unknown mass, I did get 3 grams, which was consistent with my data, giving me a 0% error. And this makes sense to me because everything has to be precise and perfect in order for my hanging masses to be equal and in a straight line. Obviously, it hangs in a straight line, and so I know that all of my masses and positions have to eventually equal 0. At first, when I tried this, I attempted to balance it all before doing any type of calculations, and then try doing calculations second, and that posed quite a issue for me and made it time-consuming and difficult. One of the hardest parts that I had was actually hanging it using my string, because I had to make sure it was going to stay balanced. This means that the tension in all of my string has to be equal to each other so that the amount of mass hanging on each is the same. To reduce errors, instead of string, I definitely could have used a hard piece of wood or something straight across, as opposed to a circular design with string would have made it a lot easier and probably a lot less error. Being constrained to household materials, though, that wasn't a possibility for me. I have a very nutritional mother in household, so we have things that can weigh in grams and really small weights, so that made it easy for me to get accurate measurements. If I didn't have that, though, it would have been a lot more difficult to get the mass of such light objects. I was surprised at how light the lightning bolt actually was, but it makes sense that it is styrofoam with the added beads.